This video is for section 9.5, polar coordinates. You will be using the student note packet also for this, for all of the graphs. So polar coordinates is, here's a warm-up. So pause the video, try this warm-up, a review of parametrics, try sketching the curve, and eliminating the parameter and writing the corresponding rectangular equation. And after you've done that, check your answer. So here is your corresponding rectangular equation. And notice you have to have the plus and minus in this. So I definitely would try that one. You might see one like that showing up again sometime. So these are our learning targets, which I'm not really going to spend a lot of time talking about on this video. So let's just get to what this is. So it is another coordinate system for plotting points. So we're used to X and Y, which we call rectangular coordinates. Now we're going to learn polar coordinates. So polar coordinates have two parts. So this represents point. And instead of an X, polar coordinates have an R, and instead of a Y, they have a theta. So the Y, the theta, is the angle. And you can think of the same angles we had for unit circle. As a matter of fact, we're going to use a lot of unit circle stuff in this section. Now the R, I think the easiest way to think of it is the radius of a circle, and it tells you the length of the radius. So polar coordinate grids also look different. I thought this had it. Let me show you quick. This is what a polar coordinate grid looks like. This is why you have those grids on your student note packet. So just wanted to point out that they're not our regular X and Y. Okay, so this just kind of also breaks down what a polar coordinate point consists of, an R and a theta. So R is the distance from that, they called this starting point the origin or the pole. Again, you can think of it just like the same origin that we have on the unit circle or on the coordinate grid. So it says the distance from the pole to the point. You can think of it as the length of the radius. And the angle is the angle, same angle that we talk about on unit circle. So counterclockwise from the polar axis, they call it. But we're going to have the same angles we talked about. So from here to here, you would have pi over 6, pi over 4, pi over 3. They're going to be exactly the same as a unit circle. I recommend you pause the video to get some of this stuff in your notes. I'm going quickly so that your video isn't too long. So example 1, they're telling us to plot these points, A, B, and C. I'm going to do them each on a separate polar grid. So remember, this represents R, and the pi over 3 is my angle. This represents the length of R, and the negative pi over 6 is my angle. So each of these are R comma theta. So in your notes, I would maybe just do A first. So first we're going to do A. Now the way you want to look at this polar grid is the first thing you want to see is, if you notice, I labeled this first angle pi over 6. So that coordinates exactly with unit circle. So if you keep counting these out, this is divided, the polar grid is divided into our pi over 6 question, or sections. Let me erase that. So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, just like on unit circle. Now you'll notice probably right away that the pi over 4s are missing. So the pi over 4 would be right here in between our pi over 6 and our pi over 3. So this would be our pi over 4, right? Just like we had on unit circle. Pi over 6, pi over 4, pi over 3. So any of the over 4s you will have to draw in on your polar grid. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. If you needed to graph a 5 pi over 4, you would draw that in. Okay, so the angle that we're interested in here is pi over 3. So you can see in the purple here, I colored in, or I traced over this whole line, and I said this angle is where theta is pi over 3. So this is where I want to plot my point, because my angle is pi over 3. Now the r equals 2, these circles correspond to r values. So this first circle is an r value of 1. So radius equals 1 is this first circle. The next circle is radius equals 2. The next circle is radius equals 3. So we want a radius of 2 and an angle of pi over 3, and we want to plot that point. So it's going to go on this line where the angle is pi over 3, and radius of 2, this is radius of 1, this is radius of 2. So that's where our coordinate point is, right there. Second circle, so a circle of radius 2 and an angle. The angle is measured just like we measure it for unit circle, an angle of pi over 3. So that would be the coordinate point 2 comma pi over 3 in the polar coordinate system. All right, now B, I would do these on a separate graph for now while you're getting the hang of this. I always go to the angle first, even though it's the y value. So I think on the unit circle, where is negative pi over 6? Negative pi over 6 is right here. If you forgot some of your unit circle stuff, start brushing up on it. This is positive pi over 6. This is negative pi over 6. So this angle right here, this entire line here, is all the r values where theta is negative pi over 6. Now I want an r value of 3. So this is radius 1, radius 2, radius 3, the third circle out. That's where I want my coordinate point. R equals 3, angle is negative pi over 6. All right, C is r equals 3 again. So I know I'm gonna use the third circle, and this time I'm doing 11 pi over 6. So if you forgot where that is on the unit circle, just start doing your counting. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So this is the angle 11 pi over 6. And remember, it goes all the way around. So that's my angle, 11 pi over 6. And my radius is 3. So third circle, 1, 2, 3. There's my coordinate point, R3, theta, 11 pi over 6. Now I want to, before we go on, I want to point out to you right now, this example and the one we just did, notice these are the exact same coordinate point, just written two different ways. Just like we found on unit circle, there were multiple ways to represent this angle, right? We said we could keep adding 2 pi. So same thing with polar. So this point, r and negative pi over 6 and r 11 pi over 6, if the r's are the same, they're going to be the exact same coordinate point. So you can represent a coordinate point on the polar grid two different ways, which I think is what the next part gets into. These are the solutions to the example I just did, so we will skip over that. Okay, this is to your turns, which I would like you to try. So I would like you to pause the video, write these examples out, do it again on your student note packet with the coordinate grid or the polar coordinate grid. Graph both of those and then unpause the video and check your answer. So for A, this is where your point should be. Third circle out for radius 3 and pi over 4. So that one you should have drawn in because the pi over 4 is not on the polar grid. And B, This should be the answer that you have. R is 2, so second circle, negative pi over 3 is down here. And again, oh, this one you didn't have to draw in. Any of the over 3s or over 6s, you aren't going to have to draw in. Any of the over 4s, you are going to have to draw in. Now, this next part is talking about how you can represent the same point two different ways. So there's a lot of words here, but this is not anything new. It's saying if you have an angle theta and you add 2 pi to it, think going all the way around the unit circle again, you're going to have the same point. So for example, if I start with pi over 6 and I add 2 pi to it, I end up with 13 pi over 6. So that's the same thing we did for unit circle. We said this angle is pi over 6, or if I go all the way around and then back up to that same terminal side, that's 13 pi over 6, but it's representing the same terminal side. So that's what this is saying. So for example, I wrote another example out here. This one gets a little weird. Notice this says r theta. I can also represent it as negative r theta plus pi. So I'm going to show you a quick example, and then we'll do some more examples. So say this is what was given, 3 pi over 6. And then I just sketched one circle here, but pretend that circle is r equals 3. So this is r equals 1, r equals 2. So here's r equals 3. So there's my coordinate point. R equals 3, and the angle is pi over 6. Now this is saying this same point can be represented by doing negative r, so I'd have negative 3, and then taking my theta here, pi over 6, and adding pi to it. So if I take pi over 6 and add pi, I need a common denominator, so that gets me to here, and I get 7 pi over 6. So this angle, 7 pi over 6, I'm going to show you on the unit circle. Here's pi over 6, here's 7 pi over 6. So they're the angle that's pi, or 180 degrees, apart from each other. So what happens when you have a negative r value? You find the angle, 7 pi over 6. So if you were graphing this point, you would find the angle, which would be 7 pi over 6. And then if your r is negative, think of reflecting that r 180 degrees or over to the opposite side. So I can't really graph a negative 3 because r is a distance. I can't have a negative distance. What the negative means is flip it over to this side. So this point, negative 3, 7 pi over 6, is graphed in the same position as positive 3 pi over 6. That's probably one of the weirdest things to get used to for polar coordinates. So what you want to think is find the angle. If the r is negative, flip the angle 180 degrees over. That's where your point is. All right, so let's try some. This is kind of saying more of the same thing. It's saying you can add 2 pi or 2 pi times any number to an angle to get the same polar coordinate point. So you could add 2 pi, you could add 4 pi, you could add 6 pi, or you could subtract 2 pi, subtract 4 pi, subtract 6 pi. This looks really confusing, and here's your negative r. But if you just look at this with different n values, what it gives you is the odds. This gave you all the evens, 2 pi, 4 pi, 6 pi. This is going to give you the odds, 3 pi, 1 pi, 5 pi. It's not as bad as it sounds when you look at those definitions. And when we try one, you'll kind of see. So the first thing it says is plot this point and then find 3 additional polar representations of the point basically on the unit circle between negative 2 pi and pi. So I would start out by pausing the video and copying this problem down. Now, I want to graph this. I notice it's a pi over 4, so that's one of the ones that I have to write in. So this would be 1 pi over 4. 2 pi over 4 is right up here at pi over 2. This is 3 pi over 4. Okay, so you have to draw in the pi over 4s. So then this would be 5 pi over 4. And 6 pi over 4. This would be 7 pi over 4. So I'm just going to draw them all in before I start this. Now, this actually says negative 3 pi over 4. So I want to count in the negative direction. So this would be negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. So this terminal side here, if you want to think about it that way, is theta equals 5 pi over 4, or theta equals negative 3 pi over 4. So this is where I want to put my coordinate point, and my R is 3. So I want to go to the third circle out, so 1, 2, 3. So there's my coordinate point. All right, so this is 3 comma negative 3 pi over 4. Now, it wants me to represent that point 3 different ways. So I'm just going to show you how you just kind of think through it using your unit circle knowledge, and then I'll show you how they do it using these formulas. So the first thing I'm going to think is, well, I did the negative angle. I know I can do the positive angle. So another way I can represent this point is still radius of 3. But instead of doing negative, I'm going to do the positive angle, which would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So there's one of the 3 ways that I can represent that exact same point. Now I'm going to think, well, I could also do the deal where I do the negative radius. So remember, when you do the negative radius, you flip it exactly 180 degrees. So if I'm here at 5 pi over 4, exactly 80 degrees, or pi in radians, away from this would be pi over 4. So this coordinate point, negative 3 pi over 4, is going to be graphed just like this. So pretend you were given this point to graph. You'd go to pi over 4, you'd go here, and then you'd say, oh, it's negative 3. So I don't want to go 3 in the positive direction here. I want to do 3 on the other side. So this coordinate point right here is negative 3 pi over 4. Now I can do the same thing again with a negative 3 using kind of the opposite of the 5 pi over 4. So I said I can plot this point as 3, 5 pi over 4. I can plot this point as 3, how do you think about this? The negative of the 5 pi over 4. So 5 pi over 4, I count this way. Negative 5 pi over 4 would be 1, 2, 3, 4, 5. So this point right here, wait a minute. Nope, I'm thinking about this wrong. So negative 3, and I did pi over 4. I want to represent pi over 4 as a negative angle. Sorry about that. So I know that pi over 4, negative 3 would be this point. Now, can I represent pi over 4 as a negative angle? If I do pi over 4 as a positive angle, I go up to that. If I do pi over 4 as a negative angle, it would be negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4. So this angle could be pi over 4 or negative 7 pi over 4. So this coordinate point could be negative 3, negative 7 pi over 4. So all of these would be that same point. Now let me show you how you could do that same thing using those formulas. So here it is. So if I take negative 3 pi over 4 that I started with, and I add pi over 2 to it, I'm going to get 5 pi over 4. If I take negative 3 pi over 4 and I minus pi from it, I'm going to get negative 7 pi over 4. If I take negative 3 pi over 4 and I add pi to it, I get pi over 4. So this is the same thing we did, but using their formulas. So I hope there's another one in here. I'll tell you what, we will kind of do this one together. So go ahead and write this one. This is the angle, and then I want 3 representations of that. So start out and pause the video and maybe see if you can just graph this one. And I'm going to remove my sheet here, and we're going to sort of do this one together. So this will be a we try. All right, so 4 pi over 3 is the same as multiply the top and bottom by 2 is the same as 8 pi over 6. So if you forgot where 4 pi over 3 is on the unit circle, it's 8 pi over 6. So 1, 2, 3, 4, 5, 6, 7, 8. So it's right here. So this is 4 pi over 3. Right? And if you forgot some of your unit circle stuff, you need to refresh your memory on that. So that's 4 pi over 3. So that is where theta equals 4 pi over 3. And I want to put my point at radius 3. 1, 2, 3. So here's my coordinate point. Now I want to represent that 3 different ways. Well, I know 4 pi over 3 was a positive angle. So the first way I can represent it is with a negative angle. So the negative angle would be negative 1 pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6. So this could also be 1 pi over 6, 2 pi over 6. Yeah, negative 4 pi over 6. And if you simplify that, that's negative 2 pi over 3. So the first way I can represent this point is with the same positive 3 radius and the angle negative 2 pi over 3. So that's this answer right here. Now, the other 2 ways I want to represent it are with the negative radius. So I know I'm going to do a negative radius. Now, the negative radius that I can see right here is this angle right over here. So this is 1, 2, 3. If I go 3 in the opposite direction, I would be here. And this angle is 1 pi over 6, 2 pi over 6, or pi over 3. So I can represent this point as negative 3 pi over 3. Now think about other ways you can represent pi over 3. We just represented it as a positive angle. You could also represent pi over 3 as a negative angle. So you would go in the negative direction all the way around to this terminal side. So I would go negative 1 pi over 6, negative 2 pi over 6, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So this angle could be pi over 3 or negative 10 pi over 6, which is the same as negative 5 pi over 3. So the third way I can represent this exact point is negative 3 again, and the angle would be negative 5 pi over 3. So these are the same angle. I'm just representing this angle as a positive and a negative. And this one is this same angle as this, represented as a positive and a negative. So you're basically doing radius 3 with the positive representation and the negative representation of the angle. And then, oh, I'm sorry, radius of positive 3. And then you're doing radius of negative 3 with the positive and negative representation of this angle. I think I'm going to do this in a separate video.